So this is just another problem, like one that you'll have on the quiz. I tried to record by hand again. My phone ran out of memory, and so for right now, I'm going to try to do it this way. I figure it's better than nothing. I've got to figure something out as far as how to record. So anyways, this is all kind of new. I'm trying to just show you guys some examples. So this question is in chapter 13, page 441. It's problem number 7. The following data were obtained from a repeated measure study comparing two treatment conditions. Use a repeated measures ANOVA with alpha equals 0.05 to determine whether there are significant mean differences between the two treatments. So this is what you're given. This table here that'll be on the test or the quiz, excuse me. You're going to create one of these tables. That's going to be step 1. Just make one just like this because you're going to need to fill this out. You won't put anything. I need to put this in here so it's not confusing because in the test it won't be asked for this. So I'm going to put an X here and an X here because you won't be asked for that. These are the boxes you'll need to fill in, and then this, and this. So there's a lot of steps to this, and the way that I do it is typically just start with what I'm looking for. So what this is a repeated measures ANOVA. You're going to have an F value that you are going to compare to the F distribution table on page 653 in Appendix B. So you need an F value in order to determine if it is within the critical region or not. So we don't know what that critical region is yet because we don't have your degrees of freedom yet. I have went ahead and put the formulas down here in the order that I would do this problem. So this is what you're wanting all to get. Like this is what we're looking for is your F, which is going to go right here. We don't have either one of these yet. So I kind of just start where I know I have some information. So there's a few things that you can do to start with. So degrees of freedom between subjects, this is the equation for degrees of freedom between subjects, n minus 1, and it's small n. Remember, small n is the number within one treatment. So 1, 2, 3, 4, 5, 6, 7, 8. There's 2 treatments. There's 8 in each treatment. So small n is 8. Big N is 16 because it's the total number. So we're going to go ahead and write this in here just so we won't forget. So n equals 8. Oops, sorry. N equals 8. Big N equals 16. Now you all understand how we got that. It's because there's 8 within a treatment, 16 total. If there was another treatment, a third treatment here with 8 more, it would be 24. So we know that degrees of freedom between subjects, n minus 1, so it's 8 minus 1 equals 7. So degrees of freedom between subjects is 7. And we can put that in this box. Next, I would go to sum of squares between subjects. This is kind of a long drawn out one. So you're going to do the summation of p squared over k, and then you're going to subtract g squared over n. So I'm going to start by, unfortunately, since I'm not doing it by hand, it's going to be a little more tedious. So summation, actually you don't have to put the summation because we're just doing the p squared. I'm going to do, so there's your p's, 8, 14, 6, 8, 14, 10, 8, and 12. And you have to do all of those over k. Now, what is k? K is the number of treatments. There's 2. K is going to be 2. I'm going to go ahead and stick that here. Okay, so the first p is 8. So I've got to do 8 squared, right? Because it's p squared. So I'll do 8 squared. This is not Super easy. Okay, so over K, which is 2. And then I'm going to do plus, because it's summation. And then you're just going to go to the next P. Which is 14 squared over 2. Go to the next P. Six squared over 2. Go to the next P. Eight. $14. N. Eight and 12. And then subtract G squared over N. So G is 80. And big N, remember, is 16. So 8 squared over 2 is 64 divided by 2 is 32. 14 squared, need a calculator for that. Let's see, 14 times 14 is 196, divided by 2 is 98. 6 squared is 36, divided by 2 is 18. 8 squared is 64, divided by 2 is 32. 14 squared over 2 is 98. I'm going to move this down. I don't think I can. Maybe I can make it smaller. There you go. Maybe that's too small. Okay. So back to this. So 14 squared, that's 98. So 10 squared is 100 divided by 2 is 50. 8 squared is 64 divided by 2 is 32. 12 squared is 144 divided by 2 is 72. And then minus 80 squared is 6,400 divided by 16. That's 400. So 32 plus 98 plus 18 plus 32 plus 98 plus 50 plus 32 plus 72 is 432 minus 400 is 32. So SS between subjects equals 32. So we're gonna put that in the table. SS between subjects, not between treatments, between subjects is 32. So then I'm going to move on to sum of squares within treatments. That's just the summation of the sum of squares inside. And what that means is sum of squares inside the treatment. So the summation of this and this, 18 plus 18 is 36. SS within treatments is 36. SS error is SS within treatments minus, which is 36 minus SS between subjects is 32. So that equals 4. So SS error is 4. Degrees of freedom within treatments is the summation of degrees of freedom inside. So if your degrees of freedom is going to be n minus 1, so n, small n, 3, so all these, so 3, 5, 1, etc. 1, 2, 3, 4, 5, 6, 7, 8. Again, n equals 8, so degrees of freedom is n minus 1, so that equals 7. And you're going to do that for both treatments because it's the summation of the degrees of freedom inside. So it's 7 plus 7 because it's n minus 1 plus n minus 1. So degrees of freedom within treatments is 14. Again, I'm going to go over that one more time because I think I confused it. So this is the small n. The number of scores in each treatment is small n. Degrees of freedom is n minus 1. Now, degrees of freedom, where did it go? Right here. So degrees of freedom within treatments is the summation of degrees of freedom inside. And that means you're going to add up in each treatment the degrees of freedom. So it's 7 because it's n minus 1 plus 7 for the second treatment, n minus 1. So that equals 14. DF error is within treatments minus between subjects. So you know your within treatments is 14 minus DF between subjects, which is 7. So that equals 7. So DF error is 7. MS error. So SS error, I'm going to do SS error is 4. DF error is 7. 4 divided by 7 is 0.57. So MS error is 0.57. Sum of squares between treatments. This is another long one. I'm going to skip down to the next line. So you're going to sum all the t squared over n and then subtract g squared over big N. So start with t. The first t is 24. The second one is 56. So 24 over n is 8. Remember, because it's the number of scores in a treatment is n, so that's 8. But we need to make sure we square 24 because it's t squared. Plus the other t is 56. So we're going to go 56 squared. Again, it's over 8. Minus g squared. G is 80. Over big N, which is 16, because that's all the scores. So 24 squared is 576 divided by 8 is 72. 56 squared is 3,136 divided by 8 is 392. And then minus 80 squared is 6,400 divided by 16 is 400. 72 plus 392 is 464 minus 400 is 64. So SS between treatments is 64. Where are we now? Let's see. We're here. So DF between treatments is K minus 1. Remember that K is the number of treatments. We have 2 treatments, 1 and 2. So DF between treatments is 2 minus 1, and that equals, of course, 1. DF between treatments is 1. So then we move on to MS between treatments. SS between treatments is 64. DF between treatments is 1. So of course that equals 64. So now we know that this right here is the first blank is degrees of freedom between treatments. So that's 1. And this is degrees of freedom error, and that's 7. And we know that F still needs to be calculated, I think, because we did not do that yet. So F, because we didn't have the parts of it. So F is going to be MS between treatments is 64. MS error is 0.57. And if you divide 64 divided by 0.57, you get 112.28. So what we do now is look at the, in the book on page 653. Of course, I could bring up this for you, and that way you can see it. So I'm going to bring up the F distribution table so I can show you how I'm using it. Done by so we need to go to Appendix B. We're looking for B.4. Oh, whoops. I guess you just have to scroll on this. The T distribution, no, we're looking for the F. Here it is. Okay, so critical values for alpha equals 0.05, which is what we want, are light fat. Here it is. Let's see. You want to use the light. So degrees of freedom, denominator, and this right here on the other side is the numerator. You see that? So what is ours? Our numerator is 1 and our denominator is 7. So here's 1. Scroll down to 7. and we want 0.05, so we're going to use the light phase here. So our critical value is 5.59 because it's 1 and then 7, 5.59. So I'm going to go back here and I'm going to type that in because we know that now. And of course I forgot it, 5.59. If our critical value is 5.59 and RF is 112.28, basically what that's saying is that our critical value is going to be right here. Let me just draw a circle, insert a shape, maybe. Anyways, this line right here is your critical value. So that is where 5.59 goes, is right where that red line or that red stops. That's 5.59. So if we are saying ours is 112 point something, that's way beyond. So that is definitely a past the critical value. So the answer to the question, are there significant mean differences between the two treatments? The answer is yes, because it is out here in this critical area. Anything over here allows you to reject the null hypothesis. The null hypothesis is that there is no difference. So you're rejecting it. So yes, there is a difference between the treatments. And then that's it for that. And I know that's a lot, but there's not going to be a ton of problems like this. I think there's literally one problem like this because it'll take you a while to get this done. But just come back to this and if you have questions and if something is not answered, then let me know.